Okay, so first, a quick little review of some vocabulary. Amplitude, the word amplitude means the maximum displacement from equilibrium. So it's how far you're being pulled away from the equilibrium position. And depending on whether we're talking about a pendulum or whether we're talking about a mass spring system, we're going to measure that differently. So in this case, the way we would measure the amplitude is the angle from equilibrium. So it's not from one side all the way to the other, but it's just from the middle to the outside like that. So that angle right there would be the amplitude. Over here, if this was my equilibrium position, meaning if I wasn't stretching the spring at all, this is how long the spring would stretch, or how long the spring would just be if it was just sitting there. Well, that's the equilibrium position, so how far I stretch that, that is going to be my amplitude. And in this case, that amplitude is going to be x. It's the same x like we were dealing with in F equals kx. And that would be measured in meters in this case, where of course over here, the angle would be measured in degrees. Okay, so you have a couple different ways of measuring amplitude, but basically it's how far away from equilibrium the thing has been stretched or pulled. Right, now, the main focus for today is to distinguish between the words frequency and period and try to understand what those two things mean. So first of all, the definition for period is the time, right? So it is a time, it's a measure of time, and it's time for a complete cycle of motion. So I have this pendulum swinging back and forth here, and if I wanted to ignore the V and the A arrows, that kind of goes back to the maximum velocity and maximum acceleration like we were talking about yesterday. But if you just focus on the pendulum itself, if I wanted to measure a full period, I would start here, let's say, and I would keep measuring all the way until it's back to where it started. So it's not just an over, it's an over and a back. So the amount of time it takes to go over and back, that would be considered a period. And since it's literally a time, the unit for this is seconds. And the symbol that we use for period, we don't use a P because that's a lot of other things in physics, but what we are going to use is a capital T. And again, that goes back to the idea that it is a time. So when I'm looking for period, I need to recognize it's a capital T, right? So it's the time for a cycle of motion. All right, now the next word that's somewhat similar is frequency. And what frequency is, it's the number of cycles per unit time. So in other words, when we have per, that's like a fraction. So it's the number of cycles divided by the amount of time. So notice time is in the denominator this time. If I think about this period one, it was the time per cycle. So time was on the top, cycle was on the bottom. Frequency, it's the other way around. Cycles is on the top, time is on the bottom. So to think about the unit for that, well, cycles doesn't have a unit, it's just a number. So it would be 1 over, and time is measured in seconds. So we would have seconds in the denominator. But we don't want to have to keep saying a 1 over second. You know, it's 5 1 over seconds. That's kind of an awkward thing to say. So we do have a special name for this. You've probably heard it before. It's called a hertz. So the unit for frequency is a hertz. And the symbol we use for that, so we don't have to write it out, is Hz. So capital H, lowercase z. Now the symbol that we use, so the variable that we use for frequency is just a lowercase f. So that's a little bit easier to remember. However, keep in mind that we also have an uppercase f. Uppercase f is force, lowercase f is frequency. So we want to be careful and not put an uppercase when we mean a lowercase and vice versa, just so we don't get ourselves confused. Okay, so tomorrow we're going to be using this simulation. So I'm just going to pull this over, and we are going to measure the time it takes this pendulum to do 5 swings. Now, the reason why I'm doing 5 swings is because if I try to time just one swing, that happens so quickly that it would be very difficult for me to not have a lot of air because of my own kind of mistakes with timing. So instead of timing one quick little motion, I'm going to time 5 swings over and back. So I'm going to press start on the stopwatch when it gets to the left side. Remember, a period is an over and a back. So I'm just going to try to count this out and do the best that I can here. So it's 1, 2, 3, 4, and 5. So it appears it took about 8 seconds. I'm just going to round a little bit for the purpose of this calculation. It was about 8 seconds for 5 swings. So I'm just going to kind of jot that down. It was 8 seconds for 5 swings. Now, if I was doing a real lab, I'd want to be a little more precise than the 8, but this just for this purpose. So this is probably one of the most important ideas for today. If you want to find the period, first of all, that's capital T. You absolutely need to know that with period, time is on top. So it's the time per the number of cycles. Okay? Time is on top. That's why it's a capital T. That's why the unit is seconds, because seconds is on the top. So in this case, I would say it was 8 seconds for 5 cycles. So I would just divide 8 seconds divided by 5 cycles. That means it was 1.6 seconds per cycle. So it took about 1.6 seconds for it to go over and back. Now, if I want to find frequency, first of all, it's a lowercase f. And what we need to know is that with frequency, time is on the bottom. So really important idea there. Time is going to be on the bottom now. So time is going to be down here, and cycles is actually on the top. So you have to know that for period, time is on top, frequency, it's on the bottom. That's why we get a unit of hertz, because we're dividing by a second. So in this case, it's 5 cycles, and it took 8 seconds. So when I do 5 divided by 8, I get about 0.625, and the unit there is hertz. A lot of times I cross my Z like that just so we don't get confusions with a 2. You don't have to do that. But it's 0.625 hertz. That means it can do 0.625 swings per second. Right? So this is the number of swings per second. So since that's less than 1, it's not even doing a full swing in a second. It's going over, it's doing more than half, and then it's doing, just a little 0.1 after that. So in 1 second, it does about that much. That's because a whole swing would take 1.6 seconds. So if I only give it 1 second, it's not even going to make a full swing. So when the frequency is a small number, that means it's not swinging very fast. In other words, when period is a big number, it's not swinging very fast. It's taking a lot of seconds to do a swing. And here, it's not doing many cycles per second. Okay, so those are 2 really important ideas. And I'm hoping mathematically you are seeing something happen here. Time or period was 8 over 5. Frequency was 5 over 8. That is, of course, a very important mathematical relationship. Those are inverses of each other. So they are what we call an inverse variation. So we get this relationship that frequency is 1 over the period, because they're reciprocals of each other, right? One was 5 over 8, the other one's 8 over 5. You flip it. Well, this is how you write reciprocals in math. So frequency is the reciprocal of the period, or the other way around, period is the reciprocal of the frequency. So you are welcome to write these things on your formula sheets. So just that, no other words or anything like that, but you can put just that part that's in the box in your formula sheet. Another thing to note here is that because time is in the denominator, when the period gets bigger, so I'm just saying the period gets bigger, like 2 seconds, 3 seconds, 4 seconds. If the period were to become a bigger number, when you divide by a bigger number, you get a smaller answer. Like if I have one pizza and I divide it by more and more friends, my piece is getting littler and littler as we go. So that is what an inverse variation means. We're going to see that a lot in this class, that when one thing goes up, the other thing is actually going down. So big period, lots of time, means a very small frequency, and vice versa. Okay, just to make sure you understand what I mean by that, I'm going to do a quick calculation. If the frequency is 0.25, I want to find the period. Well, all you have to do is period is the reciprocal of the frequency. So you literally just do 1 divided by the number. So I'm going to do 1 over 0.25, and 1 divided by 0.25 is 4. So it would take 4 seconds to swing back and forth. It would be 1, 2, 3, 4. And that's why the frequency is 0.25, because in 1 second, it's only doing this first quarter of a swing. It does a quarter of a swing in a second, or we could say it takes 4 seconds to do a full swing. Okay, this next one is the same idea, except this time I'm given period. And if I want to get frequency, I just take the reciprocal. So if I have frequency, take the reciprocal to get period. If I have period, take the reciprocal to get frequency. So whenever you have 1, you just take the reciprocal to get the other. So literally I'm just doing 1 divided by 0.386, and I get 2.59, and that would be hertz. That means it does 2, so 1, 2.5, and a little bit more swings every second. So it does 1, 2, and a little bit more every single second. So that's swinging pretty quickly. That's why the period is so small, because it's swinging pretty quickly. Okay, last thing, just to make sure we remember what goes on top, what goes on bottom. If I know that I watch 50 cycles, so I watch the thing do 50 cycles, right? That's a lot of 1, 2. I time it, it takes 42 seconds. Well, if I want to calculate the period, remember for period, it's the number of seconds per cycle. So I would take seconds divided by cycles. If I wanted the frequency, I would do it the other way around. I would do cycles divided by seconds. So they're just reciprocals of each other. That's all you have to do. So 42 divided by 50 is 0.84 seconds. So that would be the period. If I want to do the frequency, I'm going to do it the other way around. It's cycles over seconds. So you just need to know which one goes on top. So that would be 1.19. And the unit for frequency, of course, is hertz. Okay, so that's it for the main ideas. Make sure you follow the plans as far as what is going to be due for tomorrow.